Yeah, welcome to this seminar. My name is Per Astrom. I'm working as an industry sector manager within mining and materials handling for Bosch Rexroth. And I will talk about hydraulic drives that gives you a higher production rate and more reliable production to a lower cost. And before I go into this, I will talk a little bit and present the Bosch company. Robert Bosch is a global company. It's a huge company with over 280,000 employees all over the world. We are, last year we had 46 billion euro in turnover, and the biggest part is the automotive technology, delivering different kind of equipment for the automotive industry, like spark plugs, steering devices, brake systems, and so on. We also have the consumer goods and building technology. You know, the hand tools, the fridge, washer machines, security systems, and so on. And then the industrial part, that is the drive and control technology. And that is where Bosch Rexroth is working then. So within Bosch Rexroth, we have different kind of industry sectors. And within bulk materials handling, it's the heavy duty part. We have like tunnel boring machines, making tunnels, oil rigs for stationary drilling. And then, of course, the biggest part is the mining and materials handling, including cement. And when we talk about mining and materials handling, it's pretty much everything we can do, from the mine here, where we blast and excavate until you shipped it by boat, by train, or by trucks. And we are also involved in all kinds of equipment, from mobile equipment to the big machines as you see here in the porch, the loading machines or the bucket wheel stacker reclaimers, or a common truck or excavator using mobile hydraulics. Today we will focus on the mineral processing. I will talk specifically about rotary kilns, and I will go into a use case that we did last year for LKAB and their pelletizing plant. And the rotary kilns, when we talk about pelletizing plants or cement plants, is the key in the production. It's very important that they have uptime, and every hour they stand still, they lose a lot of money. So to make this kiln to rotate, you need some drive system. And when the kiln rotates, you mix the material inside here. And the balls in this case, when you have pellets, it's heated up to 1300 degrees or even more. And you sinter the materials into a hard surface or very hard material. And that's the pellets. The kiln itself is a steel tube, and its normal cases, it's 5 to 7 meter in diameter. It can be 30 to 50 meter long, and the normal capacity is between 1 to 7 million ton annually. If you talk about cement kilns, they are a little bit longer. They can be up to 100 meter, but the diameter is smaller in the other hand. Inside you have fire bricks, and these fire bricks need to be replaced or refurbished every year at least. And you see the guy standing here, so you need to stop the kiln, get rid of all the material, and then you need to inch it a little bit to be able to do the bricking here, and then they have to turn it a little bit again. And the gray area here is the steel tube, and the yellow is the insulation, and the red is the fire bricks that he's working with. And then you have the materials inside the kiln. And it's 24/7 operation. You stop it maybe once a year for maintenance. And then it's very long warm-up time and cool-down time. It can take a week to stop the kiln until you're up and running again. And that's why high availability is so important. You need to have high availability because every hour counts, and it costs a lot of money to stand still and not lose production. And also reliability is very important, because if you have an unwanted stop, then it's very important that you can turn it a little bit, otherwise you will destroy the kiln completely because of the hot material. Either it will start to bend and look like a banana between the bearings, or it will eventually break. And that's why high reliability is so important. And when the machine builder builds the kilns, they actually design it according to 3, measurements. You have the nominal torque, operating torque, and starting torque. And then you have the correspondent speed, the maximum speed, nominal speed, and the starting speed. And you also have something called auxiliary speed and auxiliary torque, and that's when you do inching or maintenance. You just turn it some degrees. And the service life is actually designed according to the operating torque. So the lifetime for the drive system is according to the operating torque. But keep in mind that it's very important that you have the capacity to manage the high starting torque. So you need to have a drive system that is efficient during operation and at the same time can manage, in this case, almost 3 times higher starting torque. And in cement, it can be 3.5 or even 4 times higher starting torque. So then you realize the difficult to find a good and efficient drive system that can be optimized for all drive cases. And normally you have a pinion and a girth gear solution. The girth gear is around the kiln, and then you have the pinion attached. This is the pinion and this is the girth gear. The drive system is attached to the pinion. And if you have problems with synchronization or balancing of these drives, you will get a lot of wear on the girth gear and on the pinion. And the lead time for this girth gear and pinion is very long, and it costs a lot of money. So that's an unwanted situation. So what we provide and prefer from Bosch Rexroth is the direct hydraulic solution, from, in this case, from Hägglunds. We have the hydraulic motor directly on the pinion or on the shaft. It's very compact, no gearbox, no foundation is needed. You just attach the motor directly on the pinion shaft. And then you can have the power unit that drives the motor further away from the kiln, so you can keep it away from the heat, the heat emission that the kilns radiates. I mean, under the kiln it can be a couple of 100 degrees. So you want to have it quite far away, and then you have the pipes connecting the power unit and the hydraulic motor. The hydraulic motor itself is a radial piston motor. It works like you have the camering here, and here is the pistons going up, in and out like this. So you have high pressure, low pressure, high pressure, low pressure. And this rotational force creates the torque and rotates the pinion. And the more flow of hydraulic oil you have to the hydraulic motor, the faster the motor will go in forward or reverse direction. So this is the principle. And as you see, for a kiln, it's very compact installation, very simple to do it. You can do it very fast, and it's also easy to maintain. So what we have done now, we have improved the hydraulic system even more, and to find a good solution for kiln drives to increase the efficiency. Because as I said, you have a contradiction. You have an operation torque and speed, and you have a starting speed that can be 3-4 times higher. And you have to have a good solution for that. So what we have now is that we have 3 different methods of, disconnecting the drive system during operation. It's A, B, and C, and now A is using a dynamic coupling, and B and C is just using the functionality inside the hydraulic motor itself. So I would like to go through this, and then after that I talk specifically about what we did for LKAB last year, when we update their kiln drive. Normally you have 4 drive system for a kiln. It's good because you balance it, you have redundancy, so it's better to have 4 than only 1, for example. It's also better from a mechanical point of view. So with method A, where we have a dynamic coupling, the idea is that we start up the kiln where we need the very high starting torque with all 4 motors, and then we disconnect 2 of them when we have reached a certain speed. And when the torque decreases, then we can disconnect 2 of the motors. And in that way, we can increase the efficiency for these 2 motors since they are optimized for the operating torque. And you see, this is the whole installation. You have the hydraulic motor here, and this is the dynamic coupling, quite compact also. Directly on the shaft, and then for a safety reason or when you do maintenance, you have a parking brake. So in this case, they have used a disc brake. You can use a ratchet wheel or any kind of parking brake, but disc brake is quite good and it's automatically controlled. The pros is that you have very good functionality with high efficiency, and you have 100%. You disconnect the drive 100% mechanically. And you also can connect and disconnect the motors on the fly. So you can, decide if you want to disconnect them at 4 RPM or 10 RPM or whatever, and you can connect them also on the fly. The disadvantage compared to a regular hydraulic drive is that you add another equipment when you have a mechanical coupling. The second solution is a built-in function in the hydraulic motor itself. In normal mode, you run it in full displacement, meaning that half of the pistons are working under high pressure and half under low pressure. You can have half displacement, meaning that 25% of the pistons are under high pressure and 75% under low pressure. And then you have the freewheeling, or you can call it zero displacement, when you push the pistons back in, so they have no contact with the cam ring, meaning that they don't add any additional torque. So they don't contribute to the drive. So in this case, you have disconnected the motors from the pinion. The third option is to use something called free circulation, and it's basically the same principle. The difference here is that here the pistons has physical contact with the cam ring all the time, but they are working under low pressure, so they are not adding any torque to the drive. And the project we did for LKAB, we selected method number A to use a mechanical coupling. So these are the motors, as you see here. And here's some real pictures. And some numbers. It's very important that you have numbers. This was the numbers before. I'm not showing their production rate because it can be sensitive, so you can see an X here. But the important is that they increased the production with at least 25%. They haven't tested it to a maximum yet because all the other equipment, like the grate, where they roll the pellets and everything, needs to be upgraded also, so they have higher capacity. The capacity increase in the speed increased by 58%. and the efficiency increased by 10%. That is quite much when you have this kind of high power application. And the lifetime increased by minimum 50,000 hours. That means that they have more than 100,000 hour lifetime now. That's more than 11, 12 years of, how to say, service life. And as I said, this project was finished last year in November. So what we achieved with this is that we improved the performance, we improved the reliability, and we increased the efficiency. We also made it possible to save the girth gear and the pinion, because that's the basic idea with hydraulics, that it's perfectly balanced, so you don't have any synchronization problems. We installed everything during the normal stop week that they had last fall, so they don't needed to stop any longer than they normally do, so they didn't lose any money in production that they wouldn't have done otherwise. So it's very fast to install this equipment, since we don't need to build any foundation or anything, we just attach it to the pinion. So to sum it up, we from Bosch Rexroth has over 50 years of experience working with mining application and different drive system. We have a lot of application know-how from all over the world. We are one single supplier, solution supplier for all kinds of drive solutions within mining. We have a modular concept that is easy to upgrade and modify. And it's very high quality products that we provide. Long lifetime, no problems, very high reliability and availability. And last but not least, we have a global local service organization. We are locally located in Kiruna, only dedicated for LKAB, just to provide them with the 24/7 service that they need. So we have the muscles to actually be a global local actor all around the world. And if you want to hear more from me and different application, we have the stand right outside here, so you just turn right when you leave this tent, and then it's stand 212, and then we can show more if you have any questions. So thank you very much.